Greetings, everybody. Dr. Latham here again, and let's work another example of integration by parts. So what we've got now is somebody's just given us an integral, asked us to evaluate the integral of e to the x cosine of x. And so again, kind of looking at what's our solution going to be for this thing. Well, we're looking at it and we're saying, hey, you know what? I see e to the x and I'm seeing cosine of x as the product two functions. And so that is going to tell me, hey, integration by parts is going to be probably the way that I want to go about solving this problem. And so for that one, we're just kind of coming back to say, all right, well, what's my integration by parts formula? So the integration by parts, the integral of u dv is going to be u times v minus the integral of v du. So the question was, how do we go about choosing u and dv in that case? Well, once we choose u, dv then just becomes everything else. And so kind of coming back again to this mnemonic that we had, LIOT, to remember what we actually choose. So we had logs, we had inverse functions, we had algebraic functions, we had trig, and we had exponential functions. And so in this case, what we've got with our e to the x, well, that one's going to be our exponential function. And then our cosine, obviously, is going to be a trig function. And so what do we choose? Well, u becomes the trig function, and dv then just becomes everything else. And so that's exactly what we're going to do. So with our integration by parts formula, we chose u to be our trig function. So that's going to be our cosine of x. dv then just becomes everything else. Everything else was just our e to the x dx. So then taking a look at du is just going to be the differential of cosine. Well, the derivative of cosine gives us negative sine of x dx for our differential. Our v becomes the antiderivative of e to the x, which is just e to the x. And then our integration by parts formula, to write that down again, u dv is going to be u times v minus the integral of v du. So that's the formula that we want to use. So then just applying this formula, what happens? Well, we've got u times v, so our u times v is going to give us our e to the x cosine of x minus the integral of v du. And so our integral of v du, so we've got v and then du down here. So that's going to give us our minus e to the x sine of x dx. So if we kind of simplify that a little bit, clean it up a little bit, what we've got is e to the x cosine of x. The minus and the minus just becomes the plus of the integral of e to the x sine of x dx. Okay, so usually what we're looking for in this case is that this second integral, does it get easier to do? Okay, well, does it get easier? Well, in this case, we can look at it and say, no, it doesn't necessarily get easier. That in this case, it's pretty much the same. And so that tells us, all right, well, have we improved things? Not necessarily, but things haven't really gotten worse either. And so one thing that we can see is, all right, well, since things haven't really gotten worse, I can't say that this is a bad direction to go for u and v. So let's just kind of not change horses in midstream and just use our integration by parts technique one more time just to see what happens. All right, so where that left us was we had our integral of e to the x cosine dx, cosine of x dx, was where we started, and so we did integration by parts one time, and we ended up with e to the x cosine of x plus the integral of e to the x sine of x. Now this one was still pretty much the same as kind of what we started with, but let's try integration by parts one more time to see what happens. Well, again, we've got an exponential and we've got a trig, so we can choose u to be our trig function. So let's make that sine of x, and dv then becomes everything else. So it's still our e to the x dx at that point. And so figuring out what du is, so du is just going to be our differential, so the derivative of sine becomes cosine of x, so cosine of x dx for our differential. V becomes the antiderivative of e to the x, so that's just e to the x. So applying our integration by parts formula, again, we've got our what we started with, so our e to the x cosine of x plus now u times v, so u times v is going to be e to the x sine of x minus the integral of v du. So v du was our e to the x cosine of x dx. Well, now wait just a second. What in the world actually happened here? We did integration by parts twice, and take a look at this. The integral that we get is exactly the same as the integral that we got when we started with. So what in the world is happening here? Well, what this really lets us do then is to really do some algebra. So for what we've got. So essentially what we have, if we kind of write this out in kind of one longer expression, so we've got the integral of e to the x cosine of x dx equal to our e to the x cosine plus e to the x sine minus the integral of e to the x cosine again. And so we'll just take this expression, our e to the x cosine, our integral of e to the x cosine, and add it on to both sides. So if we do that and add it on to both sides, so if we switch that over, so now we've got the integral of e to the x cosine of x dx plus, when we move it to the other side, the integral of e to the x cosine of x dx equal to e to the x cosine plus e to the x sine. And so on this left-hand side, now we've actually got something that we can put together. And so we end with 2 times the integral of e to the x cosine of x dx equals